Well, howdy kids. This is going to be the next video in Unit 3, Atomic Structure Notes, and we're going to talk about atomic numbers today, mass numbers, and isotopes. And we're going to learn how to distinguish between atoms that may be the same, may be different. That's what we're going to figure out today. So let's start out with atomic number. This will be our first topic today, the number of protons in the nucleus of an atom. So the atomic number is going to equal the number of protons. And some of y'all learned a while back this thing that's called ape man. And what this first part says is that the atomic number equals the number of protons, which also equals the number of electrons. And what we're going to find is that this is not always the case, because we have things called ions, which we will learn about in Unit 6. But for now, atomic number is always going to equal the number of protons. So in this picture over here, we've got two carbons, and you'll see this bottom number. Usually the bottom number is the atomic number. And what we're going to learn in a little bit is that these top numbers are called the mass numbers. But it's always going to be the same no matter what the atom of carbon looks like. So if its protons are numbered 6, it's always going to be carbon. So let's go ahead and look for the atomic number for the following elements. Now, if you're online, there's a periodic table that's posted. We ask that you go ahead and pull that up so that you can follow along with us. Otherwise, the students have periodic tables in class that we're going to look at. So if we look at aluminum on the periodic table, it's close to the center, more towards the right, but it has an atomic number of 13, which says we have 13 protons. Carbon is 6. Bromine's on the far right. It is a liquid at room temperature. That's going to be atomic number 35. Iodine is right below bromine in what we call the halogens, and that's going to be element number 53. Sodium is 11, and silver is 47. So we can identify elements based on their atomic numbers. We have numbers 1 through 118, and number 118 was discovered a couple summers ago, and there were actually several that were discovered. And so the periodic table is, in fact, complete, except one element called technetium that is kind of pesky. So how many protons are there in each? Well, they're going to be the same. It's the same number. The atomic number equals the number of protons. This is always the case. Second topic today is going to be the mass number. The mass number is the number of protons plus the number of neutrons in the nucleus of an atom. So ape man, the APE was the atomic number equals the protons and the electrons. Man is going to be the mass number equals the atomic number plus the number of neutrons. And again, the atomic number is the same as the number of protons. So we're going to go ahead and talk a little bit about isotopes, which is really the third objective today. But isotopes are atoms that have the same number of protons, but a different number of neutrons. So that carbon atom that we looked at in the first slide, it had the same number of protons, but if you notice, the masses were different, which means the number of neutrons were different. So let's look at these three elements here. They're all the same, they're all lithium, and you'll notice that the atomic number, the number of protons, is 3, because that's the atomic number for lithium. The mass numbers on top are all different. We have 6, 7, and 8. And again, the ones on top, these are going to be the mass numbers. And so if I'm looking for neutrons, I can actually take the mass number and subtract the number of protons from this equation up here. So for the first one, I would do 6 for the mass number minus 3 for the atomic, and what I would get is the number of neutrons, which is 3. And so if I did the same for these, I would have 4 neutrons and 5 neutrons. And what we would say is that these three have the same number of protons but different number of neutrons. These are all isotopes of the same element. So let's go ahead and put that into play. What is the number of neutrons in each of the following isotopes? Well, what I've given you are the elements, and I've given you all the numbers on the top, which again are the mass numbers. So what you have to do is look at your periodic table and figure out how many of each there are here. So aluminum, it's 14, but let me walk you through that. The atomic number for aluminum is always 13. That never changes. So if we go into the periodic table, we can find that carbon is 6, bromine is 35, iodine is 53, sodium is 11, and silver is 47. So based on that, all I have to do is a subtraction. Mass number minus the atomic number, and that will give me the number of neutrons. So 12 minus 6 is 6. 80 minus 35 is 45. 127 minus 53 is 74. And 23 minus 11 is 12. 108 minus 47 is 61. So I could ask you, which one of these are isotopes? Well, you would have to look for the one that has the same number of protons and neutrons. All of the others, because they have different numbers of protons and neutrons, these would all be considered isotopes. So we're going to go ahead and finish notes today by filling in this chart. We have a column for the element symbol. We have a column for the atomic number, the mass number, the number of protons, the number of electrons, and the number of neutrons. So how I'm going to work through this is one row at a time. So the atomic number, I know, is always the same as the number of protons. So I can go ahead and fill those two in. The element I can find based on the number. And if we look at the periodic table, element 12 is magnesium. I have a mass number of 25, so I know that if I do the mass number minus the number of protons, that's going to give me the number of neutrons, which in this case is 13. And because we haven't talked about ions yet, the number of protons is going to equal the number of electrons and the atomic number. Next, I have 6 protons and 6 neutrons. So I know the atomic number is 6 because the number of protons is the same. Number of neutrons plus the number of protons is going to give me the mass number. So 6 plus 6 is going to give me 12. And I know from previous slides that element 6 is carbon. And we are going to have the same number of electrons here. The element symbol on the third row is potassium, which means I'm going to have an atomic number of 19, which will give me the number of protons and electrons. Mass number minus the number of protons is going to tell me the number of neutrons. And in this case, we have, that would be 21. And last row, we have 23 electrons, so we'll have 23 protons and 23 as the atomic number, which is element letter V, vanadium. Neutrons plus protons gives me 51 as the mass number. And we're going to go ahead and stop there for today.